Now we go to chapter 9. Chapter 9 is talking relativity. Relativity means relative to something. So in this case, it's relative to the coordinate system. One inertial system respect another inertial system. What is the principle of Newtonian relativity? In those days, Newtonian said all those mechanics related with the mechanics stuff, the speed of an object is a lot smaller than speed of light. So consequently, a lot of problems didn't occur. So the thing is, in this case, the Newtonian relativity is the laws of mechanics must be the same in all inertial frames of reference. So that is what it's based on. That means at the same time, they didn't put another requirement. Means the motion of the object should be much less than speed of light. So if it's a Newtonian's reference, it's almost like the basic math is one frame respect to another inertial reference frame. So this is x prime and O pi. This inertial system is moving with the velocity of v. And this one, x and y system, is stay put. The inertial plane is stationary. Using the high school mathematics algebra, in that the drawing, x pi is equal to x minus vt, because this system is moving with the velocity of v. So in the y direction, they have no motion. So y prime equal y, and then z prime equal z. At the same time, this case is in the Newtonian system, t prime is equal to t. This means the time measurement at this moving frame are the same as this one. But in the relativity, the t prime does change. So we'll talk about that later on. In this case, the ux prime means the object in here in motion. The object motion, ux prime. How does that relate with this inertial system? So your derivative, this relationship with respect to t, then you have dx prime dt, dtx, and then minus vt, and so forth. Then you have the relationship u prime x equal to ux minus v. From this, you can derive the same thing like a uy prime equal to ux minus v, uy minus v, and uz prime equal to uz minus v. So the whole series of relative velocity is established. By the way, this one is not invented by Einstein. It is invented by or derived by Berlin. So mention one thing is important. You don't have to be, everything is come out from you. That means you have to reading history, reading the people's doing the work before, and then you come again looking at the item. Then you get some inspiration, maybe using something new. So this is the relative. So what would this, we've been playing around for the last chapter 6, chapter 1 through 6, and to physics 31A for a long time. and doesn't bother us because everything we do at the speed of an object is less than the speed of the light. So when that happens is when Michelson is trying to do the experiment. And Michelson, when he's doing this experiment, the speed of light travel very, very fast. In generally, is considered 3 times 10 to 8 meters per second. Just zap, the light's gone. So you set up this Michelson and Morley. Michelson is a professor at Caltech. He's very good with his hand. Set up the equipment and so forth. And he done that. Special project. Okay. They're all waiting for you. Thank you. So Michelson, in those days, they think the light is travel in either wind, because when the Earth rotates, the light travel under a medium called ether. So to do this experiment is not as easy as Church. You do this experiment? You're doing it, right?
Oh, he's doing by prism.
You're doing by prism or?
No, by prism. Of course not this one.
Who did the Michelson? Other people there. Gloria doing it. James Wu doing it. When this experiment was performed, right now the Michelson interferometer is small table form like this. Do you know when this was performed by Michelson? Because at those days, we don't have lasers. So we have to using mercury. And the speed of light zap is gone. So how they do it? They put this kind of setup between 2 mountains. Yeah, one is called Mount Wilson. Another one is in San Diego, in which case it's called Mount Palomar. Very, very far away. So, like the one that you are doing the experiment, like a bi-prism, you say, oh, I'm going to align it. Oh, that's Mickey Mouse a little bit. The distance is that big. Can you imagine the far away like that? Miles away. And then you're shooting the light beam. Got to be very, very accurate perform. And those labs, sometimes it takes years to perform. But what they find out, using this experiment called Michelson interferometer, they find out that ether is not existing. ETHEI is not existing. The second thing is they find out the speed of light, no matter in what reference it is, what inertia reference system is, still is travel as a speed of light. So that means in Newtonian's system, say, if this reference moves speed of light c, and the object in here move another speed of light c, so the people standing in here observing it, then this object is moving with 2 times c. According to all this development, Newtonian's formula. This guy is stationary, and the object in here moves speed of c. At the same time, just thinking about there's a bus. But the bus moving speed of light, and then the flash lamp go on speed of light. So if you do that, then 2 added together can become 2c. So then that by the Newtonian's reference. But in reality, when